Ghuglatu Sindhu, daughter of Mansingh. I am studying second year MPC. I am from College of Excellence, GV. Mathematics may not teach us how to add love or subtract hate, but it gives us hope that every problem has a solution. You may guess that today my subject is going to be mathematics. Friends, as we all know that when we sow the seed in the soil, it will germinate into sapling. After some days, it will grow into plant, and later it will become a huge tree. If we observe this function, the quantity of plant is changing with respect to another variables such as temperature, water, light, etc. Can you give some more examples from our daily life? If we observe around us, everything is changing. For example, your position keeps on changing with respect to time or surrounding. Bank balance may increase or decrease due to change in interest rate. Change in population with respect to change in years. How can we determine these changed quantities? How these changes are related to mathematics? The branch of mathematics which studies continuously change in quantities is calculus. The branch of mathematics which studies continuously change in quantities is calculus. Today, my objectives are application of calculus in daily life. Before going to our topic, let me explain you what is calculus and how many types of calculus are there. Friends, let's move. What is calculus? The word calculus comes from Latin, which means a small stone. Simply, calculus is the study of change. Calculus gives us the ability to find the effect of changes in a particular system in a particular condition. Friends, do you know who invented calculus? Sir Isaac Newton. He is well known for laws of motion and gravitation. And G.W. Leibniz, he is well known for laws of continuity. Both scientists, Sir Isaac Newton and G.W. Leibniz, independently invented calculus in the middle of 17th century. Do you know how many types of calculus are there? Calculus are mainly divided into two categories. These are differential calculus and integral calculus. Friends, there are some special terms involved in this calculus. Before explain you about differential calculus and integral calculus, let me explain you what are the terms involved in calculus. Do you guess what are those terms? Function. Here, function is a special quantity, special type of quantity where any input has a certain output. And derivatives. Derivative mean the rate of change of quantity or the rate of change of functions. These derivatives are helpful to define and to find the slope of a tangent at a point on the graph. Friends, do you know what is integral? It is the antiderivative of differentiation. The inverse process of differentiation is integral. Okay, let's enter to our main topic, that is what is differential calculus. Without having the idea about differential calculus and integral calculus, it is very difficult to do application of calculus in daily life. So, let me explain you about differential calculus. Friends, do you know what is differential calculus? Differential calculus cuts something into small pieces and to find how it is changes. The main central idea of this differential calculus is how fast something is changing at a particular time, at an instant of time. Mathematically, differential calculus is defined as the rate of change of quantity or rate of change of function with respect to another variables. That is, we find instantaneous change. The mathematical denotation for differential calculus is dy by dx is equal to limit x tends to 0 f of x plus delta x minus f of x by delta x. Do you know what is limit here? Here limit is the small change in quantity. And now let's move the topic, that is integral calculus. Friends, what is integral calculus? Integration is adding slices and to find whole. The main idea of the integral calculus is how much something is accumulating. By using the differential calculus, we can calculate the area bounded by the curve. Friends, generally we know that for square, rectangle, hexagonal, triangle, these are geometrical figures, right? For this geometrical figure, we have definite formulas. By using this, we can calculate the areas. But how can we calculate the area bounded by the curve? Then integration comes into picture. Here, integrations are used to calculate the area bounded by the curve. Friends, let's start knowing about the application of calculus in daily life. Calculus is not only contained in mathematics, but various fields has its application. Various fields enjoying the fruits of calculus. And the application of calculus in daily life, these are physics, spacecraft, medical science, biology, economics, graphics, engineering, architecture, and many more are there. Friends, let me start the application of calculus in the physics field. Friends, it is a winter, right? Daily we go for exercise early in the morning. First we do exercise, first we just walk, then we jog. After we sprint. What do you observe from this? From initial to last, our position is changing with respect to change in time. That is, the speed is defined as the rate of change of displacement with respect to time. Speed is equal to dx by dt. Here, x denotes that is a change in position. I told you that differential calculus is one quantity is changing with respect to change in another quantity. So, we have defined here speed is changing. Here speed means changing the displacement with respect to change in time. And let's move, that is velocity. Can you guess what is velocity? Velocity is the rate of change of speed. That is velocity. Here velocity is equal to ds by dt. Here ds means here s is the speed. When the speed is changes, that consider as a velocity in our physical language. And last, the acceleration. What is acceleration? Acceleration is the rate of change of velocity with respect to time. That is dv by dt. And friends, finally force. What is force? The rate of change of momentum is force, that is dp by dt. Here, if we observe these all quantities, speed, velocity, acceleration and force, these quantities are changing with respect to change in another variables, that is time. So, we can conclude that here we applying the differential calculus. Isn't it, friends? And application of calculus in physics, that is integral calculus. Friends, do you know in physics what is the formula for energy stored in a capacitor? The energy stored in a capacitor, that is work done equal to q square by 2c. To derive this formula, we should have to apply the integration. That is W is equal to integral 0 to q v dq. Without application of integration, we didn't get the whole work done, that is energy stored in a capacitor. Here we applying the integral calculus in physical science. And friends, what is the magnetic flux? To find the magnetic flux, we are applying the integration. That is, QB is equal to integral BdA. And in physics, calculus is very much needed to find the center of mass, center of gravity, and to understand the electromagnetism, we use integrations. And to calculate the velocity and trajectory of an object, to predict the position of the planet, we use integration. And friends, let us move. Friends, let me have a coffee. Whoa, it is very hot. How much time should I wait to have it? Because it is very hot. So, here Newton's cooling law said that the rate of loss of heat is directly proportional to the temperature difference between object and that of surroundings. That is, dy by dq is directly proportional to the y minus r. dy by dt is equal to k into y minus r. Friends, do you guess what is the term here y is? Here y is the temperature of the object. That is nothing but, here object is nothing but my coffee. Here my coffee's temperature, that is indicating here by y. And here r is the temperature of the surrounding. That is, one quantity is changing with respect to another variable. That is, dy by dt is equal to, we are applying here again, that is differential calculus. See friends, how wonder is this? We are applying differential calculus even when we are sip the coffee. Now let's move. It is a very interesting to us because next we are going to see the rocket, right? Next, friends, what do you observe from this rocket? Friends, we know that 2 days back, that is on December 11th, ISRO launched the PSLV C-48 vehicle. Do you know friends, how did this rocket escape from the gravitational force? How this rocket escaped from the gravitational force? Here the rocket moved against the gravitational force. The force that pushes the rocket up is called thrust. Here thrust is defined as the rate of change of momentum. Here rate of change of momentum is, here momentum is changing with respect to other variable. That is, P dash is equal to mv by dt. For the rocket launching, we should have, there is the application of calculus. Even in the spacecraft, there is the application of calculus. It is a very interesting to us. Can you guess? And next, in which field I am going to tell you application of calculus? That is space, that is astronomy. Calculus has been used in astronomy since 17th century to calculate the orbits of the planet around the stars. And to calculus is also necessary to accurately calculate the variable speeds of moving objects such as celestial bodies, comets, etc. Today's most interesting astronomical insights were gained with the use of calculus. Friends, we are using calculus. We are using calculus and we are defining the calculus. So it is very interesting us to learn the calculus. Even the application of calculus in astronomy is also there. It is the most interesting to learn about ourselves, that is biology. Medical science and biology use calculus unbelievable ways. To study the interaction of different species within an ecosystem, calculus is used. The concentration of drug in the living organism can be answered with calculus. And even physical attributes such as backbone length and skull length can be measured with calculus. Calculus is used to determine the blood flow in an artery or vein at a given point in time. Calculus is applied to find the amount of blood pumped through the heart per unit time. Friends, let me ask you that, do you know what is epidemiology? Here, the epidemiology is the branch of medicine which deals with incidence, distribution and possible diseases controlling and other factors related to health. In this field, we use the differential calculus and to determine the exact rate of growth of bacteria. Friends, I think you are so interested to learn at what time the rate of growth of bacteria, Here, are you ready to do one problem? Friends, I think you are so tired. Let's do warm up with doing one calculation that is related to biology, which is applying here calculus. So, let a kind of bacteria grow by T cube times in T second. At what time the rate of growth of bacteria is 300 bacteria per second. Again I am repeating that. Let a kind of bacteria grow by T cube times in T second. At what time the rate of growth of bacteria is 300 bacteria per second. Did you understand the problem? Here that is nothing but a kind of bacteria that is growing T cube times in T second. Here question is that find the time. The rate of growth of bacteria is 300 bacteria at what time? So, which comes into our mind, that is calculus comes into our mind to solve this problem, then problem feel happy. Okay, let's solve this problem. Let G be the rate of growth of bacteria in T second. The bacteria G of T is equal to, here G of T is equal to T cube. That is, in T second, the rate of growth of bacteria is T cube. Then, the rate of growth of bacteria that is changing. Then, G dash T is equal to 3T square. Friends, do you know how we get 3T square? Because from our differential calculus, we have the standard formula, that is d by dx of x power n. Then it is equal to nx n minus 1. Here 3t square is equal, here t cube is equal to 3 into t 3 square minus 1, that is 3t square. Then g of t is here 300. 300 is equal to 3t square. By cancelling both sides, we get t square equal to 100. For t square equal to plus or minus 10, that is the square root of 110. But here time should not be in negative. Time is a positive quantity. Then here t is equal to 10 seconds. Within 10 seconds, the rate of growth of bacteria is 300 bacteria per 10 seconds. It is very amazing, right? Because in this field, in this year, means in these days, the spreading of bacteria we can observe very speedily. Here, calculus comes into picture to calculate the rate of growth of bacteria. And friends, if a quantity or function is changing, then we can use the mathematical model of calculus to determine, optimize and predict different parameters on the system. Here, calculus is extremely useful in medical science. So, here doctors use calculus to determine the rate of growth of a tumor. The imagine that a person has tumor of small size. Doctor wants to know the rate of growth of a tumor. Then mathematical model used for modeling the tumor growth. by the exponential function with respect to time. Here we can say that here that is the constant model given, here constant the modeling of calculus given that v of t is equal to v naught e power a t. Here v equal to, v is the volume of the tumor and v naught is the initial volume of the tumor, a is the constant term and t is the time. By using the calculus, we differentiate this equation, then we get the first derivative. This helps the doctors to prevent the growth of a tumor and trajectory in the future. How interesting is this? Because nowadays population keeps on increasing. Pollution also increasing along with population. The spreading of infections, the spreading of bacteria we can observe easily, because here we can find, with the help of calculus we can find the tumor growth as well as the spreading of bacteria. It is a very important to know, because here calculus comes into picture to find the how much rate of bacteria is growing. And friends, let's move to the application of calculus in economics. Most of the peoples, they don't like maths, but they like calculation. How? They apply calculus in their economics, right? Okay. So, calculus is routinely used in economics. Economists use calculus to determine the right time to buy or sell something. And with the use of differential calculus, they find optimum solution in economics. It is very interesting, right? Even though in economics we are applying the calculus. Can you guess the term which is related to economics, even though in that field we are applying calculus? What field is this? Yes, that is nothing but in credit cards. In credit card also we are using calculus. Credit card companies use calculus to set their minimum payments due on credit card statements. At the exact time, the statement is processed by following the multiple variables such as changing in interest rate and a fluctuating available balance. In this also we are using calculus, because here the rate of interest is changing, and in this economics we are using the calculus to find the marginal values also. Next, let's move to the topic graphics. Friends, I think you are so interested to learn application of calculus in graphics. Graphics artists use calculus to determine how the different 3D models behave when they are subjected to change some conditions. This creates the realistic environment for the films as well as for video games. Friends, let's move the application of calculus in engineering. Architecture engineers use calculus, that is integrations. They use integration and to determine how much amount of material to needed to construct a curved shaped areas, that is for example dome over sports arena. And architecture engineers use calculus to build skyscrapers and bridges. Electrical engineers use calculus to determine the exact length of power cable needed to connect two substations which are miles away from each other. And here electrical engineers and computer engineers use calculus to determine their for model design. Integral calculus are mainly used for to develop the navigation system that is initially developed there. And friends, we have seen that the application of calculus in various fields. We can apply the calculus in any scenario. That weather maybe includes changes. Here, the uses of calculus are endless. If we have any problem in any dynamic situation that involves the change either motion, you can sure that we can turn to the calculus as a tool to model the problem and provide this answer. Friends, here we are using the differential calculus in integral calculus in any situation when there is a change. In our daily life, we can see the many changes. Friends, while I am coming to here from my village to city, I observe many changes. That is the speed of the car, that is increasing and decreasing. That is also the changes. And even to find the curved shape, to find the area of the tank, we are using application. So friends, the uses of calculus are endless. It plays a very important role in everybody's life. It is very necessary to learn the calculus. And here, calculus gives us motivation to learn because here the various applications are there. We are using the calculus and we are applying the calculus in many fields which are surrounded by our life. So, the calculus is a great motivator to all. Friends, from this topic, I conclude that calculus is the most important to us and we have the various application of calculus. We can apply the calculus in any field. So, it inspires us to learn calculus more actively and to use it more in the future. Because calculus is the very dynamic role. Calculus is not only mathematics. Here we observe that the calculus has various applications in various fields. So, calculus is used to determine the dynamic nature of the world. It is very important to learn calculus. So, I conclude that learn calculus more actively and try to apply the calculus in daily life and daily situation we are facing the changes. So, I am very thankful to all. I hope you understood my topic. I hope that you have understood my topic and I think that you apply the calculus in daily life. I am very thankful to my principal madam and my mathematics teacher and this TSAT news who are encouraging us to convert some topics about given topics. So, in this class, I feel very happy and thank you for all this wonderful given opportunity to me to present my topic before you. Thank you one and all.